Hey guys, I'm Priyank. Thanks for coming. I'm a developer at Thought and before I deep dive into anything, let me just give you an overview of what the talk is all about. So I think you have been here in this room since the launch, and people must have talked about different approaches that you have to develop apps on different platforms. Some of them are using the cross-platform kits, and some of them are purely native. What we are going to talk about or discuss is a little bit different. I think both of them have advantages, disadvantages. But on a real project, when we actually got on to doing it, we didn't want to lose the advantage on the native UI, but we still wanted to make sure that we have usability across platforms. And that's probably where I'm going to tell you about our architectural style that we used. It's not a toolkit. It's something that we just structure our code to, and that's how it works. So that's the gist of it. Once again, I'm Priyank. I'm a developer at ThoughtWorks. I've spent a big part of my life working with web apps and Java, and another part of it working with the Ruby on Rails apps. In my Android fever started in 2009. I've been working on apps since 2009 as my pet projects. But for the last year or so, I've had an opportunity to deliver complex mobile apps, which basically use hybrid and native approach. So I'm sure most of you must have gone through a lot of things around what is evolution, how is native different from cross-platform. So I'm not going to stick around for that. I'll just quickly go through these slides and focus on the core things that I have to say about cross-platform development. So only thing I'll say here is that basically the new age operating system for mobile that we have raised consumer expectations so much from their devices that the whole ecosystem is evolving rapidly. And if you don't evolve with it, then we are not going to leverage all the advantages that it gives us. So that being said, if a few years back you were going to make a mobile app, you would probably think, what is a platform that matters? But that's not the case anymore. It's really about what are the platforms that matter, right? So there's been a rapid shift since 2007, 2005 that you have been thinking about that. That is the platforms that matter. So you need to really consider more than one platform. And I think Apple and Android are the centerpiece of it. Anybody who you can't reach out through those platforms, you have to go through them. So those are the important things. I'm not sure if you have read the Martin Fowler's segregation on how we decide the mobile strategy. But there are two strong segregation between those. There's a laser strategy, there is cover your bases. The laser strategy is all about building an app that basically leverages your device's capability and lives as a product on your device itself. And that's not what the approach that I'm going to tell you is all about. It falls into cover your bases, which is about that you have a product which gives consumer a value. And you're using a mobile phone to reach out to a consumer and say that please use my product. So it's a channel for your product. Right? And Instagram is a good example of laser strategy. They started with iOS. They built a huge successful consumer base there. And then post that, they moved on to Android. And then each platform grows at their own rate. Zomato on the other hand has done a really good stuff on basically going to all the platforms and having leveraged that channel with all the consumers. So again, I'm pretty sure people must have talked about what is the advantages of native, what are not. Yes, you get high fidelity user experience. You can use the underlying components that the SDK provides you. And the downsides are that you need specialized sales kit. You need to worry about the feature parity on different platforms. And the development is very expensive because of the overheads. Similarly, cross-platform toolkits. I think there are advantages to that. You get reusability. You get development and maintenance. It's cheaper. And yet you can do better test-driven cycles because it's all web technology, so they are already mature enough. But the bigger downside is, and I don't know if you can read it, but it says uncanny valley. So just to quote, uncanny valley is a hypothesis that applies to the fields of robotics and 3D animation. What it says is that any replica that tries to act like human, look like human, but isn't able to act exactly like human, is going to get a revulsion from user. And if you talk about cross-platform toolkits, my biggest gripe about them is that they are not native, but they tend to be native. They try to look to a user that be a native apps, and that's where user get frustrated. And I think that's the killer point for me for cross-platform toolkits. So like I said, based on these points, we wanted to make sure that we have an app where we don't have to compromise on the UI. We don't have to say that, oh, we try to look native, but we are not native. But at the same time, we don't want to compromise on the reusability aspect of it also. We want to make sure that our code that we write is reusable across platforms. And there's no toolkit that does that already. So before we actually jump into the architecture that I'm talking about, let's quickly see what are the components that you need in a mobile app, right? So I'm pretty sure all of you already know, you need a UI, you need local data store, you need services. You need a web service and application logic. I just want to basically distinguish between last 2 points clearly before I move on to the structure, because that's where it matters. So web service is already abstracted out. You have a server somewhere, it serves the API, right? So you're not worried about on different platforms for the web service part of it, because that is already reusable across your platforms. It's only the application logic. And what does application logic means? If you are on a Zomato site and you are trying to look for a place details, then you are navigating from a list of places to a specific place. You will see phone numbers, you want to see the menu, all of those movements from one place to another. The controls that a user needs to be shown based on whether he's logged in or not. All of those decisions that live in your particular app is application logic, right? And that's what you want to make reusable. If on an Android device and on iPhone, you could abstract that out. You could say that anybody who is using the app, as long as the UI is native, but I can drive it from the central piece, that his movement is going to be to this screen or that screen, and these are the controls that needs to be shown. These are the validation that needs to be done. I think you're good, right? Because we have achieved most of the reusability there, and you want half of that. So I'm going to spend considerable time on this screen because this showcases the architecture that we have used. And before we go into that, just want to highlight one point, and I think most of you who must have worked with the cross-development kits or in web views in Java, in Android specifically, you would know that Android as a platform provides JS interfaces to communicate with JavaScript, right? So your native code can actually talk to JavaScript. It's just that the support is not that strong that your code can become unstructured if you just randomly use it across your views. Right? So with that knowledge, I also like to point out that most of the mobile platforms actually do that. They actually provide the ability to talk in the native code with JavaScript, and that's the biggest selling point for that. So leveraging that, if you look at it, we have several components in our architecture. So the green, the silver, and the blue ones that you see as iOS, Android, and web are native bits. Those components are called pages. Pages is nothing. In iOS kind of a situation, it would be a view controller. In Android, it would be an activity. And in web, it would be a hammer and a CoffeeScript, the way we use it, but you can always keep it different technologies on web, and you can use plain JavaScript. And then on the activity side, what you need to remember is that activity is not going to do any business logic. It's going to do the rendering of the view, and that's all. That's all it is going to do. Any business logic put there is not going to be reusable. So you need to make sure that your application logic is extracted out. How do we do that, or how do we put that logic? So we do controller logic. So controller logic is the component that is written in CoffeeScript. CoffeeScript can translate to JavaScript, so you might as well say that all of that is written in JavaScript. So you write all your controller logic in JavaScript. You build objects. You say that if my app is on a listing page, and I'm going to go through the flow once again in detail on my next slide. But just to give you an idea, if you're saying that I have a listing object, and I'm going to say an event that go to the next page, I can trigger that event, and my JavaScript can say that ask the view to go to this activity, right? And that activity name need not be the name. It can be just an event. And that event, as long as my activity there gets that event, it can say, oh, this event maps to an activity name XYZ, and it can just bring up the second activity, right? So that's a communication bit. Now that communication, like I said, can get unstructured if you use ad hoc web views and all of that. So for that, you have a bridge. Bridge is a thin layer that is built again for each platform individually. So you don't have a reusable layer there. You have an individual built layer for each platform, and its job is completely to communicate between your controller logic and Android. So at the end of the day, you would have a bridge that is written in your native language, that is Java, and a bit in JavaScript or CoffeeScript. You would have your Android bit, which is completely Java, and you would have controller logic, which is completely JavaScript. And then bridge is going to make sure that both of them can talk to each other, and that's the power of it. Right? And then beyond that, your app server is there, and that's where your data comes from. So once you do that, you can basically raise events from controller logic, and bridge to that fact provides you multiple APIs. What it does is, it allows you to say, yes, you can change a page on the UI, yes, you can fetch data from the server, Yes, you can raise an event with a name, or you can pass the data that you fetched from the server to the view. And view all care about it re-renders itself, or it moves to another activity. And that's the job of the bridge. I know it sounds really complex, but let's go into a sample flow and see that how it really works out. So what happens is you have a page object. Let's talk in terms of Android. So you have a page object. You have an object that is an activity, right? That activity is going to say that I am following fields, and I'm going to render it this way with this data. So in case of Zomato, assume that you are on a page which has a listing of all the restaurants that you want to look at. And now you tap on a particular restaurant that you want to go to. So I tap on it, it raises an event. So my activity will not say what it needs to do after tapping on that. What it will say is, oh, somebody tapped on an action called show me the restaurant details. And that action is passed on to the bridge. And bridge says, okay, because it's all convention based, it's going to say, if your activity was named the listing of places, maybe I need to find a controller for the activity which is called listing of places. So it goes into JavaScript and says, who's the controller which is going to own the responsibility for listing of places. And there will be a controller there which is written in JavaScript. It will have action, show details page. So that details page is going to get the results from the server. So what it will say is, I want to get the details from the server, so let me call back to Bridge and say, this is the URL I want to get the details from. And Bridge is going to not pass it to the UI, but allow you to fetch those details from the server back to itself, and pass it back to controller saying that this is the results that you are requesting for. And once that happens, controller can just give that back to Bridge and say, okay, pass this data, format it this way to the views. And that data goes to Bridge, and Bridge says, okay, now I know which, based on the naming conventions, which is the activity that needs to involve this data, and it goes to the activity there. Once that happens, activity gets the data, and a render function is called. Activity says, okay, you got a render function for a page detail in this data, I know how to render myself. So it just re-renders the native view again with that. Now that being said, I think in our observation, what we have noticed is that for most of the time, HTML5 views suffice for your views. But so I would suggest that when you build an app, you should start with HTML5 views and leverage that. Any place where you think you should have native widgets or a native UI, keep replacing those. The good side effect of that is that at the end of it, when you have an Android app, you have a free web mobile app also along with it, because you have developed all your views in the HTML5, but you replace them with the native views in some places. So you get a mobile web app for free, and you get the Android app with a mixed native and HTML5 UI if you want. If you want pure native, you can have pure native. The important thing again there is let's talk about first why it's awesome. Right? It's awesome because it gives you flexibility to choose. If you want native controls, you can get native. If you want HTML5, you can get HTML5. You can get a combination of both. And the biggest advantage that we had was we started work on an app which was already native, but we wanted to extend it out to be reusable across platform. So we right-plugged into this framework, and we could use it in conjunction. So both native and reusable code exist together in the same app. So if you have a native Android app today and you want to extend it, you can still use this approach. You get access to native component services because it's all web technologies, that is CoffeeScript and JavaScript. The TDD cycle is much simpler. Code reusability is definitely there because all the CoffeeScript or JavaScript is packaged in your app on iOS and on Android. And yes, I mean any advantage that you get with web technologies, you get it here. So a lot of people confuse it. Is it like Tidying? Is it a cross-platform toolkit that you're giving us? No, it's not. It doesn't promise you to say that you write once and you run anywhere. No, it's not that. You need native development. It's only a thinner slice. It's a framework which gives you underpinnings. It tells you which folders to place your code in and how to interact between layers, and that's all it tells you. It's a established way of communicating between your native and the web view, and that's pretty much it. You can extend existing native apps into a hybrid one using this approach. Applicability. It's applicable where your application logic is fat, where the amount of control that you need to do between activities to show data on the UI is lot. This is applicable there. It's not applicable for the apps that are dumb API consumers sitting on a phone and just doing something or showing something. It's not for those cases because you'll spend too much time managing the interaction between different layers, but you won't get the benefit of it. Finally, so this is the framework that we basically built as part of our project because that's what we started off with, and we were not satisfied with any of the solutions already available. But Jay Alexander, who's a colleague of mine, he's extracted the whole framework out into an open source library. It's called Kalatrava. I know the name is not very catchy, but if it helps you remember, he's a Spanish sculptor artist. He spent most of his life building bridges, and because this is a bridge, that's why it's named Kalatrava. It's from Cordworks. It provides basic underpinnings, and it's available in kalatrava.github.com. Key point to note, it's a alpha level library. We are still evolving it. The biggest part that is yet to come is the ability to plug in your own plugins. So that's the bit that is coming up. But do feel free to check out the architecture style. And I'm not going to say that use this, but if you figure out how it's architecture and you think it's really usable, I would encourage you to go and try to use the same style of architecture in your apps. So before we move on to questions, that's pretty much I have on the app. If you think you have some feedback for me on the talk, if you have any questions for me, you can always message me on one space why, if you like the talk, and if you don't like the talk, with some feedback. Just remember the spaces. If you can send this to this number, it'll be awesome because I'll get to know whether I should have modified the talk. Again, my Twitter handle and Twitter handles are there. It's Priyank with 3 A's. All the others were taken. So reach out to that if you need anything. That's pretty much it. Any questions that you may have? All right. So there are no apps in market. We are working on an app that is yet to be launched, and hopefully when it is, you would at least have an app to see that how it behaves, how it looks. I do not believe it will be open source, so you will not have the ability to look at the source code. But on kalatrava.github.com, there are a set of instructions. If you do go through them and follow them, you'll be able to set up a basic app, and it gives you it generates a basic app for you, which is a currency converter. And it puts all the code in the right places that you can actually go and look at and say that how they interact. So that's the only app that we have that I can say that you can actually go and look at. But I'm hoping that as time progresses and we get more time, we'll have some apps out there that you can actually browse source code for and really look at. Sure. All right. I'm sorry? Does everything concern UI? On the UI side? So the way it happens is, as part of the bridge, you preserve the application context, either with the activity context, at least in terms of Android, or use application context. We have the handle of the activities that you have on the front end in your bridge. So bridge always has a handle to what activity is being rendered on it. So if something needs to run on UI thread, it can ensure that it can actually run on UI thread because we have the handle to that activity. And there are bits that run on UI thread, but there are also bits that don't. So what we do is the controller JavaScript that we evaluate to see that what should run in the next in workflow. It is evaluated with a service that is running integrated in background. So there's a Android service that runs in background that loads up all the JavaScript, and then you can evaluate it, and then it returns a response back. On the front end, we have a web view, which basically consumes that if you're writing a views in HTML5, and basically act on it, or if you use it, views in that case, there won't be a web view there. But so some part of it, which is to have an offline, can run into services in a internet, but rest of the things can run UI thread because you maintain a handle on thread.
Is the JavaScript interpreted in web view or in or
right. So there are two places JavaScript can be evaluated. If your views are in HTML5, you have a web view, and your views are in there. You can check the native code into your web view, and you get the JavaScript interface. So any events that are raised on the UI are transferred through that to your Java. And then through bridge they are transferred back to the service which is running in the background Alright, thanks a lot,